Hey, how's it going, everybody? Today we have an amazing problem for you guys, right? So it's called valid perfect square, right? So this is a very, very good problem. So let's kind of see what's going on. It says given a positive integer nums, right? Return true if num is a perfect square, right? Or return false otherwise. A perfect square is an integer that is the square of an integer. In other words, it is the product of some integer with itself, right? You must not use any built-in libraries such as the square root function, right? So very interesting, right? So they're telling us that they're gonna be giving us a number, right? We need to find out if it's a perfect square or not, right? So how can we do that, right? It's gonna be interesting, right? So he says the perfect square, right? If we can find an integer, right, that when you multiply it with itself equals the number that's given to us, right? So if that's the case, we could say that number is a perfect square, right? If there exists a number that's an integer, right? That is, right? So we see that 16 is true, right? Because we found out that 4 multiplied with itself, right, equals the 16, right? So because of that, we found a number that fit that criteria, right? We return true, right? So just like this one, right? 14, we didn't find any integer, right? But we did find some kind of a decimal thing, right? But it's not an integer, so we didn't find an integer, so we returned 14 false as the answer, right? Because there does not exist a number, an integer, right, that fits that criteria, right? So how can we solve this, guys? How can we solve it? So what I'm thinking about, we're gonna do something very simple, brute force. So we could try all the numbers from, maybe we could start from 1 to 16 for example, right? From 1 to num. Try all the numbers out, see if we find any number along that way to 16, right? Find any number that fits that criteria, right? So we try out 1 squared equals 16, no. 2 squared equals 16, no. 3 squared equals 16, no. 4 squared equals 16, yes. We return that as the result, right? We return true because we found a number that fit that thing, right? And for this one, we would go through the whole range, right? Which is from 1 to 14 and not find anything, right? So it would not be good, okay? It would not be good at all, right? This time, this would be not too bad, right? It would be a linear, right? So of right? For time complexity. So it wouldn't be too bad, right? This would be a good start to the problem. So we kind of need to improve a bit, right? Because we kind of see that we have some kind of a sorted range, right? Like some kind of a sorted sequence, right? So that means we can kind of do a binary search, guys, right? So it's kind of screaming binary search actually. So we kind of have to do that. And how can we go ahead and apply binary search here? Um, that's the thing that we're gonna need to figure out, right? So we know it's a secret range, right? So the range is from 1 to num, okay? And maybe, yeah, and then we apply binary search over that range, right? And then applying it to that range, we could find that exact number that we're looking for, right? Which is the number that when you multiply with itself equals 16. Then we return that answer, right? If we end up finding that number, right? Because it's a search algorithm, right? So we're just using that, right? So, but yeah, I think that's what it would take, right? So we initialize a range and then we apply binary search, right? So that's kind of the main gist of the bit, right? So maybe we could go through a quick example with you guys. So this is the quick example that we're gonna be doing with you guys, right? So this is our initial range, right? So to start talking about it, right? So one of the things that we're gonna need to make sure we understand, right? So um, one of the properties, one of the rules that mathematical rules, right? That right, is that any number less than 2, right? 0 and 1, right? If it's less than 2, right, that number is the square root of itself, right? So that's why we're gonna take care of the case where if you're 0 and 1, right, we know that you're a perfect square, right? So that case can be taken care of, right? So we're not even gonna worry about 0 and 1, right? So we're gonna start search space at 2, right? And there's also another rule that you need to make sure you know, right? Is that the for any number, right, 2 or greater, right? the square root of that number, right, is not going to be greater than num divided by 2, right? Right. So, for example, let's say we're looking for square root of 9, right? Okay. Square root of 9 is 3, right? And we know 9 divided by 2 is no 4.5, which is no greater than 3, right? So we know that in that rule applies for any number greater than 2, right? Which is makes this very interesting, right? So we could upper bound, right? Instead of having it to be num, right? The number itself, right? We could make it to be num divided by 2, okay? Which is just one of the optimization that's very good, can cut down the search space, right? Okay. So now our search space becomes literally this, guys, right? Instead of going from 2 to 16, we do 2 to 8, right? Which is num divided by 2, right? So now we can efficiently do it, right? And yeah, we apply binary search here, guys, right? Which is this example, right? We see the midpoint is this, right? We check. Is 5 squared greater than 16? Yes, it is greater than, does it equal 16? No, it does. No, it doesn't, right? Obviously. And is it, so now we're going to decide to go right or go left, right? It's since 5 squared is greater than 16, we don't worry about it. We go to our left, right? Where we apply another set of binary search, right? We cheat, here's 3 greater, 3 squared greater than 16. No, it's not, right? It's less. So we remove that part. And then we only left with 4. We do binary search. We see that it does equal 16. And that's our answer right there, guys, right? So this is how we would find this one, right? Easy peasy, okay? Yeah, guys, so let's quickly go ahead with the implementation. Hopefully you guys kind of understood everything. So let's quickly do it. And so now we're gonna initialize our space, right? So first, before we even do that, right, we're gonna check. And the rule that I told you guys, right, if the number is less than 2, return true because it is a perfect square. And now we initialize our search space, right? We start from 2. And then we know that upper bound, we said it's not gonna be greater than num divided by 2, okay? And then we're gonna have a while loop, right? Standard approach, guys, right? Same thing. So while the left less than or equal to right, we're gonna calculate our thing, right? So we're gonna do this to be mid. So we do long be right minus left divided by 2. So we can also update this to long as well, guys, right? Because the numbers are gonna get, or multiplying, they're gonna get kind of big. So now we get our middle element, right? We're gonna do num squared would be mid times mid, and we check. This is where we're gonna do the check here, right? If the num squared equals to the target or equals to num, right? We return that number, okay? No, I'm tripping to return true, right? And then if that's not the case, we decide to go left or right because we're doing it efficiently, guys, right? So num squared less than num. Then we said that we're gonna go to the right. Standard, okay? Okay, otherwise we return, oh, we return false because we didn't find any we're looking for, okay? So a quick recap, right? We said any number less than 2 is a perfect square, right? And we start our bound to be from 2 because, and our right boundary is num divided by 2 because we know that the square root of a number is not going to be greater than the number divided by 2, right? That's the rule that we're using here. And then we apply a binary search to find that number, right? And then if that's the case, we return true. If not, we know we decide to go left or right, and then we don't find it, we return false. Let's press run code. See if we pass any small test case. All right, let's press submit. Awesome, guys. We passed all the test cases, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe because I'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.